Bismillahirrahmanirrahim. So here is a problem that we have to solve. Random variables x and y have the joint PMF given below. P x comma y is equal to 1 over 14 multiplied by the absolute value of x plus y, while x takes on values minus 2, 0 and 2, and y takes on values minus 1, 0 and 1, and this is 0 otherwise. Find the following: the expected value of w, which is equal to 2 raised to the power x y, the correlation of x and y, the covariance of x and y, the correlation coefficient rho xy, and the variance of x plus y. So before we begin to actually solve the problem, let us plot all the points of this probability model. So here we have, this is our x-axis, this is our y-axis. We have, suppose, minus 2 here, this is 0 here, and plus 2 here, and y is equal to minus, y takes on minus 1, yeah, minus 1, 0 and 1, 0 here, and a 1 here, right? So minus 2, minus 1, so this should be a point here, probability model, and another minus 2, and then x is equal to 0, this is y is equal to 0, sorry, minus 2, and yeah, and minus 2 and 1 here. Likewise, we can have a point here which is 0, x is equal to 0 and y is equal to minus 1, x is equal to 0, y is equal to 0, x is equal to 0 and y is equal to 1, right? And similarly we have 3 points here. So there are a total of 9 points where the probability values are non-zero, and these are 0 otherwise. So at each point we can compute the value of the probability using this expression here. So for example, the value of x at this point is minus 2 and y is 1. So minus 2 plus 1 will be minus 1, absolute value will be 1, will equal multiplied by 1 over 14. So the value of the probability at this point is 1 over 14. So we can compute the values of the probabilities at all these non-points in a similar manner. Let's put them in a table. So that will be convenient for us when we begin to solve for all these problems. So let us put these values in a table. So x can take on values minus 2, then 0, and then x is equal to 2, and y can take on minus 1 and 0 and 1, right? And we are going to compute the values of the probability. So for example, at this point, at minus 2, minus 1, so minus 2 minus 1 will be minus 3, right? And absolute value of minus 3 is 3. So this will be 3 over 14 here. And then minus 2 plus 0 is minus 2. So that will be 2 over 14 here, right? Then minus 2 plus 1 minus 1. So 1 over 14 at this point. So minus 2, 1, minus 2, and 1 is this point, right? And minus 2, minus 1 is this point here. So 3 over 14 here, 2 over 14 here, and 1 over 14 here. So in a similar manner, 0 and minus 1. This will be minus 1, so it will be 1 over 14. Then 0 plus 0 multiplied by 1 over 14, that should be 0, right? And then 0 plus 1, this should be 1, and then 1 over 14 here. Then 2 minus 1 is 1, right? And we have 1 over 14 here. 2 plus 0, 2, 2 over 14, right? And then 2 plus 1, this should be 3 over 14 here. So we have the values of the probabilities for all these 9 points now. So we can confirm that the total value of the probability, if we sum these values together, this should become out to be 1 if this is a valid probability model. So 3, the denominators are the same, so we can easily add them together. 3 and plus 1, 5, 7, 9, 10, 11 and 3, 14. So 14 over 14, the total probability is 1, so this should be a valid probability model, right? So our computations are also seem to be correct. Now let us begin with our part A, which is expected value of W, and this should be equal to expected value of 2 raised to power xy, because W is equal to 2 raised to power xy. So expected value of W is given by this double summation, x element of s of x and y element of s of y, 2 raised to power xy, and this should be multiplied with the corresponding value of the probability, right? So what it means is we need to compute first this one, 2 raised to the power, for example, for this y is x is equal to -2, y is equal to -1, so xy will be -2 multiplied by -1, so 2 raised to the power will be 2 multiplied by 3 over 14. So similar manner, we need to compute this product for all the pairs of x and y and then sum them together. So expected value of W is equal to 2 raised to the power, so x is -2, y is -1, so xy is 2 here. So 2 raised to the power 2 into 3 over 14, the corresponding value of the probability, plus x -2 and y 0, so that should be xy will be then 0, so 2 raised to the power 0 multiplied by 2 over 14 plus 2 raised to the power x and y, x is -2, y is 1, so 2 raised to the power -2, and corresponding value of probability is 1 over 14 plus let's now use this column, so x is equal to 0, y is equal to -1, so this should be 2 raised to the power 0 and 1 over 14 plus 2 raised to the power 0 multiplied by 0, this is 0, and the corresponding value of probability is also 0, so plus 2 raised to power xy, 0 multiplied by 1 is 0, so 2 raised to power 0, and the corresponding value of the probability is 1 over 14 plus now with this column, so 2 raised to the power this is 2, this is -1, so this should be -2 and 1 over 14 plus for this value 2 multiplied by 0, so that should be 2 raised to power 0 into 2 over 14 plus 2 raised to the power 2 into 3 over 14. So we have we just need to now add all these compute all the products and then add them together. So expected value of W is, this is 2 raised to power 2 is 4, so 4 multiplied by 3 is 12 over 14, right? And plus this is 2 raised to power 0 is 1, so right, so this will be 2 over 14. 2 raised to power -2 is 1 over 4, so 1 over 4 multiplied by 1 over 14 is 1 over 56. 14 into 4 is 56 plus this is 1 over 14 plus this is 0 plus 1 over 14 and plus 1 over 56 here, right, plus this is 2 over 14 plus 2 into 2 raised to power 2 is 4 into 3, 12 over 14. So this is 12 over 14 here. So we need to add these values together to find the expected value of W. So let's continue with that. So expected value of W is given by, so we have either 14 or 56 in the denominator, so we can take 56 as the LCM. 56. So the first value is 14 here, so right, so 14 into 4 is 56, so 4 into 12 is 48, so this is 48 here, then plus 4 into 2 is 8, then this is 1 here, then next 4 plus 0 and plus 4, and then 1, then 8, and then 48 again. So expected value of W, so 48 plus 48 is 96 into 4 plus 4 is 100, so 108, 109, 113, 114 and 122, so 122 and 56. This could be simplified, so 2 into 2, 4, 8, 16 and 6, 12 and 1, yes, so 61 over 28. So expected value of W, which is expected value of 2 raised to power xy, is 61 over 28. So this concludes solution of part A. So let us now begin with our part B, so which is the correlation of x and y, right? Part B, we need to calculate the correlation of x and y. So this is computed in a similar manner like we did here, only that now instead of 2 raised to power xy, we need to compute xy and then multiplied with the corresponding value of the probability. So this is given by this double summation xy multiplied by the corresponding value of the probability, right? So expected value of xy, which is the correlation of an x and y. Again, this table will help us here, right? So minus 2 into minus 1, so that should be 2 multiplied by corresponding value of the probability 3 over 40 plus minus 2 and multiplied by 0. This should be 0 here, multiplied with the corresponding value of the probability also, and then minus 2 into 1 is minus 2 and corresponding value of the probability is 1 over 14, and plus we have x 0 and y minus 1, this should be 0, right? And then this should also be 0, and then this should also be x is 0, so multiplied by 1 is 0 and this is 0, right? This column, entire column turns out to be 0 because of this x is equal to 0. Then 2 into minus 1, so that should be minus 2 multiplied by 1 over 14, the corresponding value of the probability, plus we can have 2 multiplied by 0 is 0, and plus 2 multiplied by 1 is 2 and multiplied by 3 over 14, so 2 multiplied by 3 over 40. So we just need to compute this these values and then add them together, right? So expected value of xy is given by 6 over 14 and minus 2 over 14, then again minus 2 over 14 plus 6 over 14, right? So this summation is a simple expected value of xy is given by this should be 6 plus 6 is 12 minus 2 10 and this should be 8 over 14. So 2 into 4 8 and this is 7, this should be 4 over 7. So expected value of xy is 4 over 7. So this is the correlation. This gives us the correlation between x and y. So this tells us that x and y are not orthogonal. So x and y are not orthogonal, right? So this completes our part B of the problem also. So let us now go to see our part C here. So part C is the covariance. We need to find out the covariance of x and y. So the covariance of x comma y is also denoted by sigma xy, and this is given by the expected value of xy minus the expected value of x multiplied by the expected value of y. We just found out the expected value of xy, which is the correlation, but we need to calculate the expected values of x and the expected value of y before we can calculate the covariance. So to find out the expected value of an x and expected value of y, it is better that we find out the marginal probability models of x and y. So for example, for x we can calculate here, for example 3 into 2 5 into 6, so 6 over 14 here, right? 2 over 14 here, and we have 2 and 1 3 and 3 6 over 14 here. So this will give us the probability model for x, and similar manner we can calculate the probability model for y here also. So for example 3 plus 1 plus 1, so this is 5 over 14, so this is 4 over 14, and this is again 5 over 14. 3 plus 1 5. So we can write them in a better form like this. So probability model of x, marginal PM of x, is given by, for example, so this is 3 over 7 here, this is 1 over 7 here, so this is again 3 over 7 here, right? So at x is equal to minus 2 and x is equal to 2, this is 3 over 7. So 3 over 7 when x is equal to minus 2 are 2, right? And at x is equal to 0, this is 1 over 7. So this is 1 over 7 when x is equal to 0, and this is 0 otherwise. Likewise, the probability model of y is given by this. So this is 5 over 14 when y is equal to minus 1 or 1, and this is 4 over 14 when y is equal to 0, and this is 0 otherwise. So using this probability model we can calculate the expected value of x and y, and then we can go on to calculate the variance also. So expected value of x is given by this simple summation, x element of S of x. We need to multiply x with corresponding probability value, and then we need to sum it together for all the probability values. So expected value of x is, for example, at -2 this is 3/7, at 2 this is also 3/7, so -2 plus 2 multiplied by 3/7 plus 0 multiplied by 1/7 plus 0 into 1/7. So as we can see, this is 0, this is 0, so expected value of x is 0. In a similar manner, the expected value of y is given by y element of S of y, so y multiplied by py of y. So expected value of y is given by -1 plus 1 into 5/14 plus 0 multiplied by 4/14, right? So this again comes out to be 0. Expected value of y is also 0. So this is now easy to calculate the covariance of x and y. So covariance of x and y is given by expected value of xy was 4/7, so 4/7 minus 0 multiplied by 0. So covariance of x comma y is 4/7. Right? So it means that we now have the part B, also part C, sorry, solved. Now let's find the correlation coefficient of x and y. So which should be easy to calculate from the covariance, right? So part D here, the correlation coefficient. So the correlation coefficient, which is denoted by rho xy, is given by the covariance of x comma y divided by the variance of x, variance of y, and this all square root here. So covariance we have already calculated. We just need to calculate the variance of x and variance of y before we can compute the correlation coefficient. So variance of x is given by the expected value of x square minus square of the expected value of x, right? So let us calculate the expected value of x square. So expected value of x square, which is the second moment of x, is given by this summation. This is x square and px comma y, sorry, not y here, this is PMF, marginal PMF, right? So expected value of x square is given by, so we have from the marginal PMF that we have calculated for x and y. So this is x minus 2 squared, so this would be 4, and multiplied by 3/7, the corresponding value of the probability, plus 2 squared, which is again 4, and then multiplied by the corresponding value of the probability, which is 3/7, and then x squared, this is 0, right? 0 squared is 0, multiplied, this is 0, right? So this is the expected value of x square. So expected value of x square, let me put 0 here for the sake of completion here. So this should be 12/7 plus 12/7. This should be 24 over 7. So expected value of x square, or the second moment of x, is 24 over 7. Right? So we can now calculate the variance of x. So variance of x is given by 24 over 7 minus square of the expected value. So if you would remember, the expected value of x is 0, the square is also 0. So this is 0. So variance of x is 24 over 7. Right? So 24 over 7. Now we calculate the value of the variance for y. Variance of y, before we can calculate the correlation coefficient. So variance of y is given by a formula similar to this one: expected value of y square minus square of the expected value of y. So to calculate this variance, we need to compute expected value of y square, which is given by this summation y element of s of y and y square probability model multiplied by the probability of y, right? So expected value of y square is given by, so we have this probability model of y here with us. So this is minus 1 squared multiplied by 5 over 14 plus 1 squared multiplied by 5 over 14 plus 0, right? So this is minus 1 squared multiplied by minus 1 squared multiplied by 5 over 14, right? So minus 1 squared 5 over 14 plus 1 squared into 5 over 14 and plus 0. So expected value of y squared is equal to 5 over 14 plus 5 over 14, that is 10 over 14. So this should be 5 over 7. So expected value of y square is 5 over 7. So we now have the expected value of y square also, and from this we can calculate the variance of y, right? So variance of y is given by, we now put on the values here. So this is 5 over 7 minus expected value of y squared. So expected value of y is 0, as we found out here, right? So this is 0. So variance of y is 5 over 7. So we now have the variance of x and we now have the variance of y, and we already calculated the covariance, so we can now calculate the correlation coefficient. Rho xy is given by the covariance of x and y divided by the standard deviation of x and standard deviation of y, which is the square root of variance of x and variance of y. So covariance of the correlation coefficient of xy is given by the covariance, which we calculated, was 4 over 7, right? This is 4 over 7. 4 over 7 divided by the variance of x was 24 over 7, right? So 24 over 7 multiplied by the variance of y and 5 over 7, and we need to take the square root here, right? So now, so the correlation coefficient is given by 4 over 7 multiplied by, so this is 7 multiplied by 7 and this is the square root, right? So this will come out to be 7. So 7 divided by 24 into 5 square root here, right? So this cancels out. So rho xy is equal to 4 over, this is 5 into 4, 20, and 5 to 10, and this is 120 here, and this is square root. So this is basically 4 divided by 4 into 30, and this is square root. So this 4 square root is 2, so 4 over 2 into 30 square root, so that is 2 here, so that is 2 over 30 square root. So the correlation coefficient is 2 over 30 square root. So this is the correlation coefficient of x and y. So we have calculated part D also, right? Now we are left with part E, the variance of x plus y. So variance of part E, variance of x plus y. So variance of x plus y, as we know, the summation is given by variance of x plus variance of y plus twice the covariance of x comma y. So we just need to put in the values and then calculate the variance of x plus y. So variance of x we calculated was 24 over 7 plus variance of y was 5 over 7 and 2 times the covariance of x and y. So the covariance that we calculated was 4 over 7. So 4 over 7 here. So that will be 24 over 7 plus 5 over 7 plus 8 over 7. So 24 plus 5 is 29 plus 8 is 37, right? So this is 37 over 7. So variance of x plus y is 37 over 7. So we have now calculated the variance of x plus y. Also from the correlation coefficient we see that x and y are correlated, right? So we can conclude that x and y are positively correlated, right? Positively correlated. So this concludes our solution of the problem.